So yesterday we have seen the various types of joins and the SQL commands. Now we are moving towards the views. Views are the you can see the views as windows which are given over a database. So these views are only the read-only views where you can have the different windows over the database to the different user according to their needs. So it is not desirable for all the user to see the entire database. Sometimes we would like to show only few of the columns to few of the users. In that case, the views are very useful. Views are the mechanism to hide the certain data from the view of a certain users. You can say the view is a virtual relation over a database and it is called as a view. You can create a view by using a command create view and the name of the view as the query expression. This query expression can be any select query expression which is extracting certain data in the form of table, and the extracted data will be seen as a view which is named as V. So any legal SQL query can be the query expression. The view does not store the data, it only save the expression. Why it does not store the data? Because if you change certain data, if you change certain rows, then view should be automatically updated. But if you change the data in the database, how the database can control, how the database know how many views are created over me, so that I have to update them as well. So it is creating a lot of overhead on the database to update the views as well. That's why for each and every view, the data is not stored as it is. The data is not stored in a view. What is stored in a view? In a view, we store the query expression. So whenever you are creating a view, every time this query expression is evaluated and it takes the updated data from the database, and always the view can show you the updated data from the database. Now we will see some of the example. One example is you have to create a view which show only the ID, name and department name from the instructor. How will you create such view? Create view, the name of view as faculty, as this query. This query is generating the subset of columns and it is visible as a faculty view to the user. Now you would like to create a view on the department, and in this view you would also like to generate the sum of the salaries. So views can also contain the original data as well as some of the aggregated data as well. So you can create a view as create view, you can name a view, and after giving a name to the view, you can give the new name columns as well. So this view will have two columns, that is department name and total salary, and this query will generate the department name and some salary, and it is given as a view. Again, the example of a view where we are creating a view as this query is extracting the data from more than one table. So you have to use the select from clause. In the from clause, you have to use the two tables. This query is generating the data from the two tables. Only the selected columns are extracted and that can be given to the view of physics fall 2009. On the view itself, you can do the query, means you can create a view overview. We have created a view of physics fall 2009. From this view, you can extract the data and few subcolumns, and you can create a new view which can be given as a new name, physics fall 2009 Watson. So meaning to say is that you can create a view over the view. You can also expand the use of view in the query or the other view. Like this view is we have to first calculate the inside query. This inside query is creating some table. This table is used in the from clause. From this from clause, you can generate the two columns, and from this, in these two column, you are doing the horizontal filtering where building name is Watson, and you are storing that select whatever has been selected by this query, that can be generated as a view like this. Now, how the views are maintained, how the views are materialized. As I have said that in the views, it is not your system DBMS is not storing the data. The DBMS will maintain the view by storing only the query expression. Whenever you are accessing the view, every time that query expression is evaluated and you can get the updated data. The main problem in maintaining the view is how can you get the updated data, because on the database multiple processes are updating the data and your data is constantly changing. How to make sure that your views are also getting the changed data or updated data? The transaction I am leaving for now. We will see it in the later chapter as a separate one. Now we are moving towards the integrity constraints. The integrity constraint, we will see how can it be implemented in the SQL and what is the role of the integrity constraints. So integrity constraint says that only the authorized users can make the changes, and whatever changes you are doing, it is correct one. It is maintaining the data consistency. What is the meaning of data consistency? If your your bank balance is stored in two tables and you are updating your bank balance in one table, automatically it should be changed in the other table as well. Otherwise, both table contain your balance amount as a different, is a inconsistent data that is not at all acceptable. So integrity constraint says that your data is always consistent, it is always correct. What are the different integrity constraint you can use? The one type of integrity constraint can be the one type of integrity constraint can be you can check for certain values of a column. Certain values of a column means you can check my age is not greater than 100. This amount balance is not greater than this. So this is one of the type of, in each and every column, in each and every cell, you can check for the constraint. The second type of constraint, you can check for the not null value. You do not allow the null values. Such type of constraint can also be incorporated into the database. The third type of constraint can be the primary key. Primary key is also a constraint. How the primary key is constrained? Because primary key says that what primary key, say for example, you have to select a column or set of column to identify it as a primary key. So to identify a column as a primary key says that in that particular column, all the values are going to be unique. So if you try to, hello, hello, चलेगा. It will make you sure that every time whenever you are inserting a value into the database, that primary key value should always be unique. No duplicate entries are allowed. So it is again a integrity constraint. It will make sure that our database is always correct. The second type of integrity constraint can be the unique. This unique integrity constraint is a candidate key. I repeat, the difference between the candidate key and primary key is that candidate key and primary key both are minimal set of the attribute which identify your each and every row uniquely, but out of the multiple candidates key, we select a single key as a primary key. Rest of the keys are the candidate keys. So the candidate keys are the unique key, but the unique keyword allow you to enter the null data as well. So, but primary key does not allow you to enter the null data. So unique is a candidate key, and the primary key is one key has to be identified for every table that is a primary key. Check P is a predicate. You can check for any column value. You can check age greater than 100, age less than 100, like this. For every column, you can write a predicate, and this database will check for you whether it is true or not. Now we will see how these integrity constraints can be used in the database. We will first see for the not null integrity constraint. This not null integrity constraint means I do not want to allow some of the columns as I do not accept the null values for some of the columns. Then you have to, whenever we are declaring the column in the command of create table name varchar 20 not null. So you have to define like this. So this integrity constraint is associated with name. Budget numeric not null. You cannot accept the null value, so you have to define it as a not null. Whenever user want to enter the null value there, it will throw an exception and it will not accept the null values. Now we will see the second type of integrity constraint, that is a unique. So unique integrity constraint, you may have to give the set of column names which uniquely identify your rows. So this set of column names which uniquely identify your rows is a candidate key, but in this case you can allow them to be the null. Null is allowed, but in case of primary key the null is not allowed. Now we will see check P. Check P is to check whether P predicate is true or not. Now see the example of check P. You created a table. You have given the column names. Now you can give a check. Check, and then you have to give the predicate. What is the predicate? The predicate says that the value of semester in either fall, winter, spring or summer. If the semester value fall into this, then the value of that predicate is true. Then only it allow the semester to insert. Look at this. Semester is a column name of type varchar 2. Whenever you are inserting a value for the semester, it will check that the value of semester should be out of these 4 words only. Now we will see how other integrity constraint can be incorporated. At the time of create table, you can define your column name. If they are not null, you can assign with them not null, not null. After defining all the columns, you have to write primary key. Which fields combinedly create a primary key, that you have to define here. Then the other constraints like check and foreign key as well. Now we are coming to the referential integrity. The referential integrity says that we are referring to two tables, and the value that appear in one relation for given set of attribute also appear in the certain set of attribute in another relation. The example is that if you have two tables, in one table you are storing one table you are storing the name of department as biology, and the instructor, it is an instructor table. Instructor table may we store the name of instructor and their associated department. Say for example, Latesh Malik, department name is computer science. So instructor name along with the department name is stored into the instructor table. The another table is a department table. This department table has the name of department, building, average salary, and number of rooms, and so on. In this department table, we also has the department name. So department name is present in the table of instructor, as well as department name is present in the table of department as well. So in the instructor table, the department name, or what we are using in the department name, it is referring to the department name of department table. Now we will see the basic concept associated with the primary key, foreign key, and referential integrity. In this case, whenever we are defining the referential integrity or the foreign key, we need to have two tables. The two tables, here we are taking the two tables as S and R. We are taking R and S are the two relations. In these two relations, one attribute A is common. This attribute A is primary key in one relation and foreign key in another relation. So it is always a case that whenever you are defining an attribute as a foreign key, then it should be an attribute as a primary key in another relation. So foreign key is always associated with the primary key in another relation. Look at this. A is a primary key of S, and A is also a foreign key of R. Then any value of A appearing in R, these values also appear in S. Look at one example. This we have taken this student database. This student database has student ID, first name, last name, and course ID. And the other relation has which course ID is associated with which course name. Now we are learning the concept of primary key, foreign key, and referential integrity. So you can see that these are two tables, and the course ID is common field between these two tables. In these two tables, this course ID, you can see it is a primary key in this table. With every course ID, you have a course name. Or which student is learning which course. Here, these are the course IDs which student is learning this course. You can see that it is not primary. You can have the multiple values. The multiple student can learn the same course ID. So it is not a primary key here. But it is a primary key in this case, in this table 2 mein, it is a primary key. This course ID is referring to this. You can see that course ID will only be the entries which are present here. Whatever course are offered, that can only be given here. So it is referring to this one. So whatever, this is a foreign key in this table because the foreign key always refers to the primary key. It is called as a referential integrity. If you are defining the concept of primary key and foreign key, it is a concept of referential integrity. Why it is a concept of referential integrity? Because say for example, if I delete A004, means that course does not exist. If you delete this, it means that automatically the students who opted for this course, that row should also be deleted. If the course is not offered, how can you offer it to the student? So automatically that deletion should take place. So this is the case of referential integrity, means we are maintaining the integrity of data. If you are deleting a course, the students who opted the course should also be deleted automatically. How can you do this for the referential integrity? How can you define the primary key and foreign key? Look at the example, this course, it is a course relation, course table. In that course table, we have the course ID, title and department name. This department name is this department name is referring to this department name is a foreign key here, and this foreign key is referring to the other table, and the other table is it is referring to the references, and the table name is department. In that table, this department name should be a primary key. So these are the two ways to write the same thing. You just look at this. Both of the queries can be written. They are alternate to each other. You can write either in a first way or in a second way. In the second case, we also have used a keyword of cascade. This cascade says that if you are deleting a data from the primary key, then automatically in a cascade way, it should be deleted from the foreign key, foreign table as well. The cascade also refer to if your table is referring to if a primary table is referring to foreign and the foreign table is referring to another table. So it will do the deletion in all the referring tables in a cascade way. Then you have to use the keyword as delete that cascade. Now we will see how can you create the index in the SQL. You must be knowing that what is the meaning of index. The index is, you have seen that in a dictionary or in a book you have an index. The index will ease our searching process. You can directly see the topic, you can directly go to that particular page and you can get that contents. So index can also be created in the table as well. How can you create the index? You can create the index by using create index, and the name of the index, you can give a name to the index on student ID. Student is the table name, and on which field, on which column you would like to create the index. So it will create an index for you. If you have created an index on ID, you can make the searching on ID very fast. You can create an index on name, you can make the searching on name very fast. So in that way you can create the index and it will ace, or it will make your searching process very fast and efficient. We already have seen the data types, so I'm not repeating them again. Now we are coming to the authorization and the various other type of you can say the privileges which you can give to the users, which you can give on the databases. You must have seen that in Windows also we give the guest access, we give the admin access, and the different type of other access are available in the operating system as well. The same can be done in the databases. We have the multiple users who are working on the database, so you can give the different rights to the different users. The first type of authorization which you can give to the database to the user is a read, which allow the user to only read. Insert, which allow the user to insert the data, but it does not allow you to modify the data. To update the data, you have to give the authorization as an update. To allow the deletion, you can give the authorization as delete. The other form of authorization which you can give at the, you can say these above authorization were on the data level, but these authorization are on the structure level. You can allow such type of authorization on the structure level, where user can create the indexes, user can allow the creation of resources, user can alter the column names, user can drop the tables. Such type of authorization can also be given. How can you give such type of authorization to users? In SQL, the command is grant, then privilege list, and on which relation and to the which users. So first is privilege list. The privilege list can be, say for example, you want to give the select, update, insert, such type of grants. On which relation? Relation is instructor or department or other relation. To which user? There are different users, maybe guest, user 1, user 2. The users can be created by admin. Note this third point. The third point says that if you have granted a privilege on the view, that does not imply that privileges has been given to the relation as well. View is only you have given up a read only data, but even if you got certain privileges on the view, that does not say that you got the authorization on the table as well. What are the different privileges? One is select, that will allow you to select query. Then you can have insert, update, delete, and all privileges means all the privileges. Look at the example. Grant select on instructor to user 1, user 2, and user 3. The way you grant the privileges, you can revoke the privileges as well. How to revoke the privileges? Revoke privilege list. Which privilege would you like to revoke? Select, insert, delete. On which relation? From which users? Which you want to revoke? Revoke select on table name branch from U1, U2 or U3. The way we create the users, you can also create the roles. The roles, creation of roles says that you can give the different user defined role to the different users. Say for example, I have given a role of instructor to a user. So whatever rights are available to the instructor will be available to him. Grant instructor to Amit. So Amit will be able to enjoy the authorization which are given to the instructor. So that names can also be maintained by using the create roles. Grant select on table name takes to the instructor. So you can use these role names in place of username. So we have given a username certain roles. You can also give the authorization of the on the views. As we said that giving an authorization of view does not mean that authorization is given on the table also. It is only on the view. So there in the view also you can give the authorization in the same way. Grant select on this view to which user. The commands are same. Instead of the table name, we are using the name of the view. The other option which is available to the authorization is with grant option. What is the meaning of with grant option? The with grant option says that if you have given certain authorization to the user with grant option, the same authorization can be delegated by that user to the another one. If you have given a select on table name department to Amit with grant option, Amit is able to delegate that select on department to other user as well. It can delegate that same powers to other one if it has got with grant option. In the revoke, you can use the cascade. The cascade means, okay, Amit, if say for example, Amit has given this select to the Santoshi, and then if you revoke it, then it says that revoke from yes cascade means Amit has given this grant to the Santoshi. Automatically, if you are revoking from the Amit, from the Santosh, it is automatically revoked. So it is revoked in a cascade way. Now we are taking the gate problems on the SQL. The problem that we are taking is we have been given a two table A, B and C, D. A, B is R1 and C, D is R2. In this, the B is a foreign key and it is referring to the C, which is a primary key. And if R1 and R2 both satisfy the referential integrity. Referential integrity means the B is a foreign key and the C is a primary key. It follows the referential integrity. Then which of the following is always true? Which of the following is always true? We will first see the first case. What is the first case? It is extracting the value B from R1. So it is a project operation. It will get all the values from B. So all values will be extracted from this. And all values C from R2 are extracted. Now you can see that B is a foreign key. B में जो भी डेटा होगा वो डेटा कहीं ना कहीं C में जरूर होगा because it is a foreign key. Every data which is present in the B is present in the C also. So if you subtract the pi B minus pi C, the subtraction says that the data which is present in A not in B, then you can see that all the data which is present in B is present in C also. So this will be giving you the null. So this first expression is true. भाके को बोलो ना तो भाके The first expression is true. The second expression is not true because in the primary key section, in the primary key, you can have the more data which is not present in the foreign key. So in the primary key, you can have the additional data of C which is not there in the B. So it is not going to give you the null. The same you can see they are not equal and the reverse is also not true. So its answer is A. I will be sharing this DOC file with your sir and you can see the explanation also. This query we had solved in the previous class. Now we are coming to the next question. This question says that in the table you have two columns A, C. A is a primary key and C is a foreign key. This table is referring to itself. It is a referring to it. We can call it as a self-referencing table. And in this table, you are operating. We have to do. In this table, you can see that C is referring to A. How the C is referring to A? You can see that this 2 is, if it is a 2 means it is referring to this row. If it is a 2 means it is referring to this row. If it is a 3, it is referring to this row, second row. If it is 4 means it is referring to row number 1. So you have to see the columns and then you have to mark it is referring to which one. 4 is referring to this one. This 4 is referring to this one. So it is referring to, it is C is a foreign key and A is a primary key. Foreign key always refer to A. So you have to draw like this and arrow will be on the side of primary key. Now this question says that if C is a foreign key and A is a primary key and it is a delete cascade, then the question is if you delete the tuple 2, 4, which are the tuples will be deleted automatically? We have seen that whenever you delete a row from the primary table, whatever foreign key records which are referring to the primary key, they are automatically deleted. The record of primary key is deleted means automatically the foreign key records are automatically deleted. So if you have deleted to this, you have deleted to 2, 4. This is deleted. Means the rows which are referred to this are automatically deleted. Which will be deleted? This 5, 2 will also be deleted because you have deleted 2, 4. This 2, 4 is deleted and it is referring to this 2, 5 will also be deleted and the 7, 2 will also be deleted. Then if you have deleted 5, 2, you can see that this 5 is also referring to this. This 5, it is referring to this one. Means if you have deleted this one, means it is going to delete this as well. 9, 5 will also be deleted because it is a cascade delete. If you are deleting 2, 4, this records which are referring to 2 will be deleted. And if these 2 are 5, primary key is deleted, means the foreign key 5 will also be deleted. This way, it is going to delete the 3 records which are 5, 2, 7, 2 and 9, 5. So this question is asking which other records will be deleted, that is 5, 2, 7, 2 and 9, 5. Now see to the other question which is asked in the gate. Given relation are w, x and y, z. And you are executing the query, select distinct w means it will take the unique values of w, x from r, s is guaranteed to be same as r. It says that this query is going to give you the result same as r relation. In which case? how this query is going to display the result same as that of table R. You can see that in the from clause, even though it is using R comma S, but it is not using a data, it is not extracting anything W comma X. W comma X is present in R itself. So table S is not used here. It is only to create the confusion. So what is the condition that it is going to create only R? It is going to create only R. The first condition says that R has no duplicates and S is not empty. It is if R has no duplicates, because you are creating the distinct W. So if R has no duplicates, and then S we have nothing to do with S. So uh, it is non-empty, and even if it has table, we have nothing to do with it. It is creating distinct W means all the entries in R should be the distinct one. They have no duplicates. Then both of them are same means relation R, and this query is generating the same result. Look at the other option. R and S have no duplicates. Because if R has a duplicate, it is not going to give you the same result. SQL is creating the distinct one, and this has the duplicate, so it is not going to be the same. So second is not true for our case. S has no duplicate. S is not at all relevant to us. R and S has same number of tuples, that is not relevant to us. In this case, S is not at all relevant to us. You only have to, because this query is using only W comma X, which is present in R itself. So the distinct entries, if the distinct entries are present in R, both of them are same. Now the other question is, in the SQL, the relation can contain the null values, and the comparison with null values are treated as unknown. Suppose that all comparisons with null values are treated as false. Which of the following pair is not equivalent? In this query, this null part is given to confuse you. You only have to focus on the data. Look at this, which data is equal, which of the two options are equivalent, which are not equivalent. The first option, you can see that X is equal to 5. Not and not will cancel means both of the options are equivalent. You have to give the not equivalent option. Second option is X is equal to 5. It is, and X greater than 5 and less than 6 means X is going to be the 5. Both of them are equivalent. So B option is also equivalent. X is less than 5, not X is equal to 5. So it can be greater than, it can be less than also. So it is not equivalent. So C is the answer. So you only have to see the data. You should not be confused with the first part, which is dealing with the null one. The next question is, which is true about the SQL query? The first part is saying that an SQL query can contain the having clause even if it does not has a group by clause. It is not true. We have studied that having clause is filtering the data after groups. So whatever groups are created by using the group by clause, having clause is going to filter the data which group should possess. So this P option is false. Second, the Q option, a SQL query can contain a having clause only if it has a group by clause. It is correct. Then the third option is all attributes used in the group by clause must appear in the select clause. It is true and false both. In some of the SQL, say for example Postgres or some of the standard SQL, it is true. because it allow you to give all the group by clause should appear in the select clause. But in some of the SQL, it allow you to skip also. You cannot display them also, but here we assume that it is true. Now we will see the S. Not all attributes used in the group by clause need to appear in the select clause. It is false. All attributes should appear in the select clause. So Q and R is the Q and R is the option, that is a C. Here we are assuming that we are looking at the standard SQL. We are not focusing on any SQL compilers which are available in the market. They are giving you the different versions, but we are referring here for the standard SQL, which says that group by clause में जितने भी whatever attributes you are taking for the group by, they should come in the select clause also. In addition to them, you can use the aggregate function in the select clause. Now the next question is based on this data. So we are first looking at the data. The first data is table A, which consists of ID number, name and age. Table B, which also consists of ID number, name and age. And table C consists of ID number, phone and area. Now the question is above table A, B, C, if you execute this query, how many rows will be extracted? How many rows will be extracted? How do you calculate? First, you calculate this part of the query. You have to see the B table. From the B table, you have to extract the age. For which age? You have to take the age of Arun. So B table may say we will see the age of Arun. Look at the B table. What is the age of Arun? In the B table, the Arun entry is not present. How can you get the age of Arun? So this part of query is going to give you the null value. Arun is not present in table B. It is giving you the null value. So table B is giving you the null value. Then you have to give select AID. You have to give the select AID from A where A dot age is greater than all, and here you are going to get the null value. Means all the entries present in the A will be extracted. All AID will be extracted. How many entries are present in A? In A table, 3 entries are present, and it is going to give you the 3 number of rows. I again repeat this query. You have to first solve this part of the query, which is in the bracket. This part of the query is giving you null value. No record is extracted. If no record is extracted means you have to take the age which is greater than null. All the ages are greater than null. So all entries present in table A will be extracted and you will get the number of rows as 3. Now look at the another example. In this example, you have table T which consists of column X, Y. And this column X, Y initialize with X is equal to 1 and Y is equal to 1. It is inserted with one record, X is equal to 1 and Y is equal to 1. After that, the second record will be second, third, fourth record will be generated. How they are generated? They are generated as value of X is going to be this MX value is 1 and MY value is 1 initially, and they are generated as value of X is going to be the MX plus 1 and value of Y is going to be 2 into MY plus 1. That way you have to generate your table. How this table is generated? Look at this. You started with 1, 1. Second will be mx plus 1, that is 1 plus 1, 2 into my plus 1, that is 2 into 1 plus 1, that is 3. So that way you can generate the second row. Third row will be mx plus 1, that is 3, 2 into my plus 1, that is 7. Fourth row is mx plus 1, that is 4, 2 into my plus 1, that is 15. So you have to do it for 128 number of times. You have to do it for 128 number of times. Now, if you have generated this table, you have to extract this query. Select y from t where x is equal to 7. Means you have to extract the value of y where x is equal to 7. In this table, look at this. If the value of x is 7, then what is the value of y? It is asked in the question. The value of y is 127. So 127 is the answer. That is it. You have to do. Again, look at this question. X comma x is equal to 1, y is equal to 1 is inserted. Mx and my will denote the maximum value of x comma 1, x comma y among all the records in the table at any point of time. Then using mx and my, you have to generate the new records and you have to do it for 128 number of times. And values generated are mx plus 1 and 2 into my plus 1. And that way you have to do generate first table, and then out of this table you have to execute this query. When the value of x is 7, what is the value of y? Now the next question is, we have been given a table. In this table, the name of this table is loan records, and in this table you have 3 columns: borrower, bank manager and loan amount. What is the output of this SQL query? Whenever you are, this SQL query says that select count star and then from and then this. First of all, you have to first calculate the data in brackets. What data will be generated here? Look at this. This is select bank manager from loan account. You have to select bank manager. You have to select bank manager comma loan amount. Then you have to take this bank manager and loan amount and store it as a table T. Bank manager, loan amount, store it as table T. How it will come? Bank manager, loan amount, store it as table T. Now we will solve the second bracket. Second bracket says select borrower comma bank manager from loan records. In this you have to extract borrower comma bank manager and store it as S. Borrower comma bank manager, store it as S. Now you have calculated S comma S and T both. So you have solved first bracket, you have solved second bracket. Now you have to do the natural join between S and T. How to do the natural join between S and T? Look at the table. S table has borrower and bank manager. T table has bank manager and loan amount. You have to do the natural join. The natural join says that on the common field, common entries are merged. On the common field name is bank manager. The common field name is bank manager and it is going to merge in the bank manager. After doing the natural join, how the natural join will take place? Look at this. In the natural join, we have this Sundarjan 2 times. This Ramesh Sundarjan will merge with Sundarjan 10,000 and Sundarjan 7,000. This Ram Gopal will merge with Ram Gopal. This Mahesh Sundarjan will merge with Sundarjan 10,000 and Sundarjan 7,000. In and all, you can see that you will be generating total 5 records. First Sundarjan is merged with these two Sundarjan. The Ram Gopal merge with only one Ram Gopal, 3 records. This Sundarjan will also merge with these two Sundarjans. So finally you are going to get 5 records. This query is asking us, if you natural join table S and table T, how many records you are going to get? So the answer of this query is 5 records you can get. Its solution I have given in the table in this file. After doing the natural join, you can see you will be getting these 5 records. Sundarjan will be merged with all the other two Sundarjan. So Sundarjan is creating 4 records and Ram Gopal is creating 1. In all, the 5 records are created. Now we come to the next question. This next question has the two tables, that is a passenger and reservation. In this passenger and reservation, the PID column is same. Now we will see what question has been asked. The first table is dealing with the passenger PID, and that passenger, what class and what seat has been allocated, that is a reservation. So passenger ID is common field. The passenger ID, this is the passenger data which is given, and this is the reservation data which is given. Now you have to solve this query. Look at this query. Select PID from reservation, where clause, AC, and this one. To solve this, first you have to solve this bracket. Whenever you are solving a query, start from the bracket and get the data. What will be the data for this? You have to select star from passenger whose age is greater than 65. So look at the rows in the passenger whose age is greater than 65. Whose age is greater than 65. Again, we have to see that which are the passengers whose age is greater than 65. The age which is greater than 65 is, you can note down, they are the ID number 1, 2, and 3. Whose age is greater than 65. 1, 2, and 3. Then this is the second part of the query. And at the same time, you have to see only the entries which has the same PID. Its PIDs are 0, 1, 2, 3, 5. 0, 1, 2, 3, 5 means 1, 2, 3 are the part of it. So our subquery will be giving you 1, 2, 3. Now we will come to the first part. The first part says that you have to select the PID where class is AC. In this case, which are the PID which has the class AC? They are 0, 1, 5 and 3. 0, 1, 3, 5 are the IDs which has the class AC. Now you have to see that 0, 1, 3, 5 and the second query had 1, 2, 3, which are the common one. So which are the common one? They are 1, 3. So answer is 1, 3. The second part of query is giving us 1, 2, 3. The first part of query is giving us 0, 1, 3, 5. It is an AND between them. So you have to take the common one. They are 1, 3. Now the next question. In this question, you have been given 3 tables. The first table is dealing with suppliers, second table is dealing with the parts, and the third table is dealing with the catalogs. Now you have to see this query and you have to find out what the query is doing what. The solutions are given as like this, what it is doing. To see this, we have to start from the bracket, what this bracket is doing. This bracket is selecting all the part IDs whose color is not blue. Whose color is not blue. Now look at the second part. We will go hierarchical from bottom to top. So bottom part is extracting the rows which are not blue. Its color is not blue. If it is not blue, you have added it as a not in. Not in means that not will be cancelled and it is going to say it is blue. It is going to give you all the parts which is blue because two nots have become positive and it is giving you the blue. Again come up, this come up, it again says that it is not. Means again it has become not blue. So it is giving you all the part name from the supplier whose part names are not blue. So that way you have to give the answer. It is giving you the name of suppliers who are not blue. So this A answer is true. Look at the other answer. Name of all the supplier who have not supplied. No. The name of all the supplier who have supplied only blue. No. Name of suppliers who have not supplied. No. It is only 3 not. 3 not will become not blue. So it is giving us all the supplier name who have supplied other than who have supplied not blue parts. Now come to the another question. This question is, it is an employee. The employee has this. It is an employee. This employee has the columns employee ID, name and department salary. And we are executing the two queries. The two queries we are executing, assume that it's department 5. Department name is 5. Department number 5 has more than one employee and we want to find the employees who get higher salary than anyone in department 5. Whosoever is getting the salary higher than anyone in the department 5, which query is doing for you? You have to say this. So it is we have seen that whenever you want to compare a salary with salary in the same table, you are doing the self-referencing. The same table has to be Cartesian product with the same table and you have to give the different name, table T and table S, compare the T salary with S salary, and you have to get all the employees which has salary higher than department 5. Look at query Q1, what it is doing. This query Q1, first we will solve this bracket. This bracket says that select star from employee S, where S dot department is 5 and S salary is greater than E salary. We are referring to the S department 5 and S salary is greater, means department 5 salary is greater than E salary. Department 5 salary is greater, but we are interested in the salary which is greater than 5 department. The 5 department salary should not be more. So this query is not correct. S is department, S dot department is 5 and S salary is more. We are not interested in S salary more. We are interested in S salary less. The S salary less. So this query Q1 will never be giving you the correct result. Now we will see the query Q2. This query Q2 again see to the second part. The second part says that you have to, it is selecting the distinct salary from department 5 and it is extracting all the employees whose E dot salary is greater than any of the salary from department 5. So Q2 is the correct one. It will be giving you the correct answer. Q2 is the correct answer. First, it is extracting the salary from department 5 and whosoever is getting the salary more than department 5 will be output. Now consider the another statement. The given statement is you have been given this query and you have to tell which statement is correct. Now first understand this query. This query says that you are creating a table S. In this table you have a column A, D, E, integer. You are creating a primary key on D. Foreign key is A, which is referring to relation R. Means this A is a foreign key. A is a foreign key and in relation R, A is a primary key. Now you have to learn, now you have to read the statement number S1. The statement S1 says that a foreign key declaration can always be replaced by an equivalent check assertions. Check assertion was check P. So can you do it? Foreign key assertion or a referential integrity can be done with the check predicate. It is not, it cannot be. The things which can be done by foreign key and primary key cannot be done by check. The second part is given table ABC where A and B together form a primary key. A and B together cannot form a primary key because in the foreign key A, it is the foreign key A is referring to R and A should be the primary key. Combination of A and B is not allowed. So is the valid definition. S1 and S2, both of them are false. Both of them are false. They are not correct. Now come to the next question. Given the following schema, employee and department, you want to display the last name and the hire dates. Last name and the hire date of latest hires. Hire date of latest hire means recently hired, updated hired, and for the location ID 1700. If you issue this query, what is the outcome? We will first understand this query. Look at this bracket. This bracket is finding out the department name and hire date maximum. Hire date maximum means in this query, this query is getting the data from the employee and the department and it is joining these two tables on the department ID where location ID is 1700 and group by department ID. So it is giving you the department ID and their maximum hiring date. So this will be giving you the department ID and maximum hire date. And the first query will extract the data and it will check for the membership. If it is there in the department ID and hire date, it will be extracting the data. So what is the outcome? The outcome is this is a correct query and it will be giving you the correct output. So it will be giving you the correct output. Now the next question is, in this question, SQL allow the tuples in the relation correspondingly define the multiplicity of the tuples in the result of joins. Which one of the following query will always give you the same results as that of query given below? In this query, it is giving you select star from R where A in. It is going to first extract this. What it says, it is going to extract S dot A from S, and it is a set. You can see that in a set, even if some duplicate entries are there, but in set they are automatically removed. 1 comma 1 is same as that of 1. 2 comma 2 comma 2 is same as that of 2. So duplication is never be there in the set. So if this subquery is there in the set, automatically the duplicates are removed. And if A is present in A, it will be giving you the output. So which query is similar to this one? The query which is similar to this one will be using always the distinct keyword, because it is removing the duplicates from the set. So it will be select distinct, always be the distinct from R, where R dot A is equal to S dot A. So B will be the answer, where it is also doing the same, R dot A is equal to S dot A, but it is removing the duplicate in case of set. So the distinct keyword is must. Now take the another one. In this example, you have been given employee and the customer. In this example, the sales representative, this one, is a foreign key in this. This sales representative is a foreign key in the customer, and it is referring to the employee ID as a primary key in employee. Sales ID is a foreign key and employee ID is a primary key. Sales ID, rapid ID is referring to employee ID. Assume that each of the employee make the sales at least to one customer. It says that every employee record will come here. Every employee record will come here because everyone is selling to someone, some customer. So what will this query return? This query is, again we will first solve this bracket. What this bracket is doing, this bracket is selecting from the customer table. It will be selecting all the data from the customer table whose rating is not good. Whose rating is not good, and the not is combined with not, means not good has become good now. So this query will be giving you all the employees' name whose rating is good, who has sold something to the customer and whose rating is good. So you have to select the option. It will be the name of the all employee with at least one, no. Name of the all employees with almost one, utmost one, no. None of one, no. It will be name of the all employees with all their customers having a good rating. So it has become a good rating for all. So every time whenever you are solving the query, you have to first solve from the bottom and from the bracketed. Solve the brackets first, then solve in a hierarchical way. You will definitely get the answer. So that is it for today. We will continue in the next class.